Good morning, students. Welcome to the class of mathematics. So, students, today we will try to solve one question numerical based upon collision. When the collision is with a one is a one-dimensional, and when a body strikes with another body, when the other body is a very heavy mass, like a wall, like a ground, the earth. When a ball is dropped on earth or ball is hit on a wall, like this. Okay. So in all that type of collisions, a concept of coefficient of restitutions will come, and how it will be arrived, we'll try to solve that question. So here we will just initiate with this concept that the question is that a wooden ball is dropped vertically on a horizontal plane. So when the ball is dropped horizontally on a horizontal plane, then definitely at that moment the total which is achieved kinetic energy achieved will be coming from the potential energy of that ball when it is kept at h1 height. If the ball is here, it is dropped from height h. The ball is dropped from height h, then kinetic energy equal to half mva square. This will be equal to mgh. The formula potential energy. Okay? And E square can be written as m and m will be cancelled out over here, and v square can be written as 2h and v equal to under h, and we'll calculate the velocity after a strike. It will also attain some velocity v1 v3, and that ratio, this ratio from this formula we are coming to the coefficient of restitution concept. So the coefficient of restitution, what is that? Coefficient of restitution is represented as E, and its value is always taken as positive. That's why we taken the mod of the final velocity, initial velocity. Okay, what is that? That is root over h2 divided by root over h1. This is E. Okay, so this is the coefficient of restitution, and whenever the question is given on this, we will use the same formula. Okay, so I just come through this so that we'll be able to solve this numerical. Now the question is that a wooden ball is dropped from vertically on a horizontal plane from height 2 meter. So h1 is given 2 meter with an initial velocity of 0. If the coefficient of restitution of the ball with respect to the floor is 0.5, that means the 0.5 is the coefficient of restitution. So here we can write what coefficient of restitution. That means E equal to 0.5. This will be equal to root under h2 by h1. by root under h1. And what is the value of h1? See here, h1 is 2 meter. That is the initial. Ball is dropped vertically from that height, 2 meter. So h1 will be 2 meter. Okay, we'll put the value over here, 2 meter. And when we solve it, just squaring the both side, it will be 0.25 equal to h2 by, that means h2 equal to zero point 0.5 meter. So the ball is rising to height of 0.5 meter after striking from the ground. So we get the value of h2. h2 is 0.5 meter, right? Now we'll come to the second part. The first part is solved. Okay, the first part is solved and it's a 0.5 meter. This one is solved. The second part is the amount of heat evolved during the impact. The mass of the ball is 100 grams. Students, the amount of heat evolved. Okay, the amount of heat evolved. How we'll get that? The amount of heat evolved equal to delta of mgh, potential energy at h height, h2 height. Then after the collision, we will again having the potential energy of at h1 height, that is mg h1. So the difference of both the potential energy will, that change will lead to the generation of heat. That is the amount of heat evolved. Okay. So this will be mgh2 minus mgh1. The mass of the ball is always same. It's 100 gram. So we'll be dividing it by 1000 to convert it into kg. 100 gram into g. Take it as 9.8 meter per second square. Meter per second square, and h2 minus h1. Know what is H2? H2 is here. So we'll take the value of this H2 here. That is 0.5 meter minus what is the initial height H1. Here it's you can see it's 2 meter. 2 meter. So 2 meter will be subtracted from this meter. So the result will be this will be 980 divided by 1000 into 1.5. So it will be a negative sign. Okay, so if we to put it over here. Why this negative sign? This negative sign shows heat liberated or evolved. Value will be when we multiply it 98 into 15. So it will 98 into 5 by 4, 5 by 4, 5 and 498 9 so 770. This will be 1470 divided by 100 in the negative. So it will be 1.0 and 0 will be cancelled out. This will be at 98 into 15. Okay. This will be coming as 1470. 1470 divided by 1000. 1000. Okay. 10 will be extra here. It will be coming as 1.47 joule. So this is the energy which is liberated. Okay. So the energy liberated is 1.47. Will come up to the. So we have solved the second part also. So just coming on this 1. Yeah, 1.47 joule, which is the amount of heat evolved. Heat evolved. That is. So students, we have solved these questions and we'll come up with some more conceptual numericals based upon inelastic collisions and elastic. And what is the coefficient of restitution we have seen over here, and how to solve this we have gone through this. So keep on learning and definitely will succeed. And subscribe to my channel. Happy learning.